Hi everyone. In this last lecture video, I'm going to talk about the internal validity issues with experimental designs. The choice of experimental design can influence both internal and external validity. Remember that internal validity is about measuring what you think you're measuring. We've spoken already about how internal validity can be influenced by our operationalization choices, but this can also be influenced by spurious relationships, which I've already mentioned, that can impact by your experimental design. External validity is all about generalizability. In our sampling lecture, we learned about the importance of representativeness. But like internal validity, the way that an experiment is designed and how the participants interact with the experiment can influence this concept. The ways in which validity is affected by the experimental design are called threats to validity. Your textbook describes a number of different threats. For the purposes of this course, I'm going to focus on a few select ones. For each threat to the validity, you need to understand what the threat means, what experimental design decisions create the threat, and what experimental design decisions can eliminate or at least reduce the threat from occurring. I've organized all of these threats into the acronym Dr. Smith. So let's start with D. D stands for diffusion and demoralization. Diffusion means that some of the treatment gets diffused down to the control group. Think of this example. I give all of the students in a classroom a survey about prejudice. I then take half the students into a different room and I show them a video about inclusivity and diversity. I then put the group back together and have them all take the same survey again. What's the problem? The main issue here is that both groups of kids are immediately going back into the same room. So it's pretty expected that the movie watchers will talk about the movie to the non-movie watchers. So now the control group will get a little bit of the treatment, even though they weren't supposed to get any. Any study that has an experimental group and a control group, and whose groups have contact with another during the experiment, is going to face diffusion threats. To protect against diffusion, you can either not use a control group, which isn't a great design choice, or you can separate your groups out so they can't interact until the experiment is done. So maybe instead of all the students in a single classroom participating, we take classroom A and make it the experimental group, and we take classroom B and make that the control group. Now all we need to do is make sure that A and B stay apart during the experiment, and we've eliminated the threat. Demoralization works in a similar manner, as it requires interaction between the experimental and control groups. But demoralization is about the control group getting frustrated or upset and then giving up. If all those movie-watching kids from the first classroom got a cookie while the control group got nothing, it may upset the control group children and make them less likely to respond honestly to the post-test survey. Like diffusion, keeping the two groups apart can eliminate this threat. You can also provide a placebo incentive to the control group, like they do in medical studies, so that it looks like the control group and the experimental group are getting the same reward. The R in Dr. Smith stands for regression to the mean and reactivity effect. Regression to the mean means that people who score extreme scores in either direction will often change regardless of the intervention. For example, a student who scores in the lowest 1% on a math test is likely to improve their score over time, even without intervention. So you have to keep in mind that some changes to scores, particularly those from people at the extreme ends of the scale, may not be because of your intervention. And repeating the research study multiple times can help you identify if it's just regression to the mean or if something is actually happening with your independent variable. Reactivity effect occurs when the novelty of engaging in research or reacting differently because you're in an experimental situation. This is also referred to as the Hawthorne effect. Here's a short video about this effect. One of the best ways to reduce a reactivity concern is to use a natural experiment or to use the Solomon four-group design that you learned about earlier, because this is going to limit the number of observations that are conducted on some of the groups in the experiment. Which brings us to S. S stands for selection bias. Selection bias can occur in two ways. If there's a difference between those who volunteer for the study and those who do not, then the sample won't look like the population. This creates selection bias that then threatens our generalizability, which reduces our external validity. Almost every study that uses surveys or interviews has selection bias because inherently, whoever agrees to be part of the study is going to be different than the people who disagree. Unless we eliminate voluntary protection or participation, which of course is an ethical requirement, then we risk selection bias in those research studies. Another way that selection bias can occur is when there's a difference between the control group and the experimental group. Substantial differences in the measured characteristics between the two groups will make comparisons between them invalid, thus influencing our internal validity. The fix for this type of selection bias is to use random assignment or matching strategies to achieve equality and representation between both the experimental and the control group. On to M, which stands for maturation and mortality. These issues are only relevant for longitudinal research studies because they only occur when there's at least 2 time points that data is gathered at. Maturation is about the changing of our personalities, our behaviors, and our opinions over time as a result of natural maturation processes. If I were to gather data from this man at each point in time, his answers are going to be different. This wouldn't matter what my independent variable is. It would just be a regular part of life. The best way to reduce maturation is to decrease the amount of time between time 1 and time 2. That reduces the risk that I will mature enough to create distinct changes during the experiment. Mortality is, as expected, about subjects that drop out of the study for one reason or another. They may die, they may opt out, or they may simply not be able to be found by the researcher. Remember, I called this same issue attrition before, and it still means the same thing. The problem is that if people drop out, then I may not be able to make conclusions with the same data because I'll collect less at each subsequent time point. Once again, the fix here is to reduce the time between data collections so as to reduce the opportunity for mortality. Another option that's available if you cannot reduce the time period is to obtain a larger sample size than you actually need and to randomly assign the experimental control group. That way you have a participant buffer that allows some mortality to occur, and the random assignment assures that this mortality is equally likely to occur in both groups. Instrumentation is one of the few threats to validity that the researcher has complete control over. Instrumentation occurs when the measurement method used in the pretest does not match the measurement method used in the post-test, thus making the comparisons between the two invalid. The easiest way to avoid instrumentation? Keep the instrument the same at both times. In criminal justice, one of the most well-known issues of instrumentation is the changing definition of rape in the Uniform Crime Report's data collection. The original definition was, quote, the carnal knowledge of a female forcibly and against her will, end quote. Now, obviously, this definition is gendered, so that it only applies to female victims, and it requires both penis to vagina contact, force on behalf of the perpetrator, and resistance on behalf of the victim. In 2013, the UCR definition was changed to a new definition, shown here. Quote, penetration, no matter how slight, of the vagina or anus with any body part or object, or oral penetration by a sex organ of another person without the consent of the victim, end quote. This new definition specifically avoided gender terminology so as to apply to both male and female victims, and the acts of penetration were expanded to include penetration of any body part by either a sex organ or an object without consent. As you can see, the force and the resistance stipulations are also removed so long as consent is not given. When you look at the UCR data, the FBI segregates the data from 2013 and beyond from the data that's gathered previously because it's acknowledged that the definitional changes create major changes in the reporting. For instance, the 2012 rate of rape in the United States was calculated at 27.1 instances of rape per every 100,000 people. The 2013 rate of rape rose substantially to 35.9 instances of rape per the same 100,000 people. The UCR labels each of these rates as belonging to the legacy definition, meaning the original, or the revised definition. Researchers who use rape statistics from the UCR have to avoid making direct comparisons across time periods because of this change in definition. Okay, we're getting close there, I promise. We're all the way down to the T in Smith. T stands for testing effect. Testing effect occurs when a subject learns the test and changes their answers on the post-test accordingly. This may be purposeful. For example, if I was to give everyone a survey about recycling and then have them watch a video about the advantages of recycling, then the subject will clearly understand that I'm trying to influence their recycling behaviors. So they may be more inclined to lie on the post-test and report a more positive view of recycling than they actually feel because they understand the point of the test itself. Now, the testing effect can also occur unconsciously. For example, the College Board reports that the best way to earn a high score on the SAT is to take a practice test. Why? Because you learn the test. Taking the test multiple times makes you more comfortable with the process and the format of the test itself, making it more likely that you're going to earn a higher score. Research suggests that 2 out of 3 people will see an increase in their SAT scores when they take the test again, even if they take the second test right away. Now, I'm not saying that the testing effect will make you a genius on the SAT, but it may provide a small increase in your score. The only way to eliminate the testing effect is to use a cross-sectional design, because this eliminates the pretest and the subject's ability to learn the test. But now, of course, you've introduced more error into the process. Remember the Solomon 4-group design I showed you in the first lecture video on true experimental designs? The Solomon 4-group design is perfect for identifying and controlling for the testing effect because one of the experimental groups gets a pretest, but the other experimental group doesn't. So the researchers can identify if the pretest is causing a problem in the experiment by comparing the 2 experimental group outcomes. Okay, we've almost made it. We are on the H in Dr. Smith, which stands for history. Now, history is a really confusing term, and if I were able to rename it, I would. Because when we think of history, we think of things that happened in the past, right? But in research methods, the history threat to validity is about things that happen during the experiment that are outside the researcher's control. This is the example I use every year because it just highlights the history effect more than anything else. Let's say you conduct a survey with college students asking about their views towards immigration on September 10th, 2001. You then have all of the students watch a movie that highlights the various ways that immigrants have contributed to scientific breakthroughs and economic victories in the United States. 2 days later, you have the subjects come back and take the same survey again. What's the problem? September 11th, right? The World Trade Center attack occurred right in the middle of your hypothetical study. And as you can imagine, this attack had a substantial impact on people's attitudes towards immigration, among other issues. So your movie is likely completely irrelevant here. But how can you know that for sure? The way to control for history is to use a control group. Even college students who didn't watch your film on immigration are going to show a change in the pretest to post-test values. This is your clue that something is going on outside of your independent variable that you need to account for. Well, that concludes our module on experimental design. I know this is a lot, so again, remember you can always rewatch these videos if you need to refresh your memory. I also have some videos about the threats to validity available on my website under the additional resources page. Thanks for watching, everyone.